Kubernetes, as we know, is a very complex system. Managing and securing it requires a lot of planning and expertise. Role-based access control, or RBAC, which is the topic of this video, is just one aspect of overall Kubernetes security system. And as such, I provide a brief discussion on overall Kubernetes security in this section. Kubernetes has a layered architecture, as we can see from the picture below. Each layer has its own security requirements and settings. This layered architecture provides defense in depth, which is highly effective and desirable, provided that these layers are properly protected. So let's talk about some of the security best practices regarding these layers. So as we can see that the Kubernetes is either hosted inside our corporate data center or inside the cloud. Either case, then we have the cluster itself, which consists of one or more masters, which host the API server. There's also the etcd or the Kubernetes database, which saves and manages all the configuration and settings. And then we have worker nodes, which provide a hosting environment for the pod. So the pod or container can be then installed on them, deployed on them. And then within the pod, then we have the actual application itself running. So let's talk about some of the best practices. So regardless of whether the environment is hosted internally or in the cloud, the access to the cluster must be protected through traditional firewall and IPsec, etc. Within the Kubernetes cluster, access to master and worker nodes must be restricted. Kubernetes nodes use client certificates to communicate with the API server. So these worker nodes, they use client certificates that are installed, that are issued by the API server, and they are saved on each node. So if a hacker gets hold of, breaks into one of these nodes, then he or she will have access to those client certificates. Then we can use them to communicate with the API server and etcd and do a lot of damage. The control plane is at the heart of the Kubernetes cluster, obviously. etcd is the data source for all Kubernetes information and settings that we talked about. If compromised, you should assume that the cluster is compromised. So if etcd either can be installed on the master or it could be installed on a different server. If it's installed outside the master, then it must be protected. So it is recommended to set a firewall that will allow only communication from the API server. And also it is recommended to set up MTLS or mutual authentication between the API server and etcd. Access to Kubernetes resources such as pods, services, secrets, etc. must be regulated and tightly controlled. People and service accounts must be given enough permissions to perform their function and not more. This is then done through RBAC, which is the subject of this video. Pods running with unconstrained security privileges, such as running as root, will pose serious security threats to the worker nodes and potentially to the entire clusters. By default, actually, pods run as root, which is not a good thing because, again, the hacker can use that privilege to attack the worker node, and through that, then it can attack the control plane. So there are some techniques that can be used, which is beyond the scope of Discord, such as setting leveraging the pod security policies, and also OPA, which stands for Open Security Agent. So these are more advanced topics. I started off with this RBAC security discussion. If there's a desire from you guys, we want to know, kind of dig deeper into Kubernetes security, let me know in the discussion area, and then I can arrange for future to do more Kubernetes security in the future. So let me know. And within the cluster, pod-to-pod communication, like here, should be regulated through network policies. So we talked about network policies in the previous episodes, using the default Kubernetes network policy or use more advanced security policies that are provided through CNI, such as Calico or Cilium. It is also recommended that pod-to-pod security be encrypted. So again, those are more advanced topic that we can talk about those in the future if there is desire. Again, we already talked about the security, the network policies. They're not necessarily to add to that, but we can talk, dive more into other aspects of security, such as pod security and so on. Again, let me know if you'd like to understand more of those topics. The API service security rests upon three pillars of authentication, authorization, and admission control. Authentication means who can interact with the API server. Authorization means what are they allowed to do. Admission control means does the object being persisted breaks any policy rules. So if you're deploying an object such as pod, are there any policy attached to that pod creation? And if so, is that policy being violated or not? So let's take a quick look at Kubernetes authentication model. So every request that comes into the API server, such as a user interacting with the API server, or a pod wants to talk to the API server, or a worker node wants to interact with the API server, the requester needs to be authenticated. And the authentication architecture in Kubernetes is plugin. So an administrator can enable various methods of authentication as described here, such as X509 client certificate, which is a default method for the users to authenticate to Active Directory, to the API server. And also the worker nodes, they also use client certificates. But there's other options such as OpenID Connect. So these are for users, and these are external services, systems that can be set up to use OpenID Connect protocol. So basically users will need to go to will be directed to a different system. They put in the user ID and password, and the system will generate a token for them. This token is sent to the API server, and then the API server can verify that token is valid again by contacting the OpenID Connect server. And this is how the authentication occurs. So note that the API server does not save users. There's no way for you to create users through Kubernetes itself. So it all relies on various plugins that you can use, such as again certificate or OpenID. And static token provides another way of authentication in this method. An administrator can create users and assign to them tokens and upload those into the API server and then to the etcd, and then the user can authenticate. So this is not a really good way of authentication for big systems. This is very for small systems. And then there's another way of doing that authentication is through webhook. Webhook really provides a gateway to other authenticators, such as directory services, either on Windows, such as Microsoft Active Directory, or Linux-based directory services. So in any case, when the users, once the user is authenticated, then they need to be authorized. Again, authorization has a plugin model, and administrator can enable one or more of these methods. Role-based access control, attribute-based access control, webhook, and node authorization. Let's go through those very quickly. So RBAC, which is again the topic of this video, is role-based access control. This is a method of regulating access to computer or network resources based on the role of individual users or service accounts within an enterprise. ABAC is an alternative to RBAC, and it provides an access control paradigm whereby access rights are granted to users through the use of policies which combine attributes together. The policies can use any type of attributes, such as user attributes, resource attributes, object, environment attributes, etc. So this is a more fine-grained authorization than RBAC, but it's really a lot more complicated. So for the most use cases, I would say RBAC is preferred way of doing that. But if you have scenarios where, let's say you want to grant access based on the user that logs in certain, during certain time in a time zone, then that would be ABAC. But again, for most use cases, I would recommend using RBAC. And webhook, again, like the webhook authentication, is an open way for delegate authorization to a different outside system. And node authentication is a special purpose authentication method that specifically authorizes API resource requests made by kubelets. RBAC, or role-based access control, consists of 3 tenants. The first one is subjects. So subjects could be people like Terry Jones, or could be a service account of a pod. The next tenant is resources. So what resources we want to give these people access to. There are 2 types of resources. The first one is cluster scope. So these are objects or resources that don't have any, are not associated with any specific namespace. So such as nodes, storage classes, persistent volumes, certificates, signing requests, etc. The second type of resources are bound to specific namespace, or they are namespace scope, such as pods, services, daemon sets, deployment, etc. The last tenant is operations or verbs. That is, these represent permissions such as get, list, watch, delete, so on. So these are the verbs. So basically, the RBAC consists of giving access to people or service account, access, and that access could be permissions such as get, list, watch, and so on to specific resources. So that's really the whole basis for role-based access control. Now, note that the resources in Kubernetes, they are represented by as RESTful service. So in order to, before we can give users or service account access to resources, we need to find out where they are. So these resources are again represented by a service, by a RESTful service, and there's a hierarchy involved here. So in the next demo, we're going to look at the hierarchy and how we can identify where to find the resources, so we can give different people or service account specific permissions. So to connect to the API server and take a look at the hierarchy, first we need to establish a proxy. So on line 2, kubectl proxy and the ampersand, and that will establish a connection or a proxy between this machine and the API server. I've already done that, so I'm not going to run that, but you need to do that before you go to the next line, which is now, you can take a look at the overall hierarchy of the API server. The command is curl http / localhost, and the port number is 8081. If we run that, you'll see that it shows you all the hierarchy or the API that are involved here. So let's go scroll up. And we'll go to the top here. And you can see there are various path underneath, such as /API, /API v1, /APIs, and so on. We can also drill into a specific one. For instance, we have API /v1. So if we want to, we can actually go deeper in that. So curl HTTP, again, localhost 8081, and then the path that we were looking for, that is API v1. So let's go ahead and run that. And it will show us the objects that are under that path and also the verbs they support. So let's go all the way up here. There's a lot of them. So this is actually one of the oldest APIs that was created. For instance, this resource and the resources, it shows us the first one is bindings. And then it shows the kind, the namespace. Is it namespace or not? Or is it like cluster scope or namespace scope? And this is namespace scope because it's the binding. And the verb that it supports is basically create. There's only one thing that it supports is create. And so on. So we can look at, for instance, next one is config map. And then let's go a little bit, scroll down here. And then we'll see it now supports a lot more verbs. So we can assign various verbs to a user, such as create, delete collection, get, list, patch, update, and watch. So this is one way that we can explore what is involved, what resources are and API groups and what resources are available. The other thing that we can do, let me go ahead and get rid of this. We can actually directly go to the resources, and this is the command that we can run, kubectl API-resources -oy. So let's go ahead and run that. And this is kind of a shortcut. If you are looking for something specific, we can go here and take a look at this. So we'll see how it has a name, the short names, the API version that is under the name, it is namespace or not, the kind. So this is similar to the information that we saw running the API raw, but this is a kind of more refined view of looking at resources and the verbs that it supports. For instance, again, the bindings, as we saw, is under v1. Is namespace, as we saw, is true, so it's namespace bound, and the kind is binding, and it only supports one thing, and that is create. And we looked at the config map also, as we saw again. The API version that was under namespace true, the kind is config map, and these are the verbs, all the verbs that it supports. We can also do more, if you're looking for a specific one, for instance, on line 15, I'm looking for daemon set. I want to see where exactly in hierarchy it is, and also the verbs that it supports. So we can do the same thing, API version, API-resources -oy, and then I pipe it into grep, and I'm looking for daemon set. So this is just our daemon set. And you see that these are the information that we are looking for. So this is under API apps v1 and namespace true. So it's namespace bound. And also these are the verbs at the support. So in order, before we give permission to resources, you need to find, to look at where they are under what API, and also in the hierarchy, and also you need to understand what are the verbs that it supports. So let's just take a look at the more detailed view of how RBAC actually works. So as we mentioned earlier, there are resources that are cluster scope, such as nodes, persistent volume, etc. We also mentioned that there are other types of objects that are namespace scopes such as pod services, daemons, etc. We also mentioned that there are users or subjects that we can give access to these objects, and those access or operations or verbs are the ones that are shown here, such as get, list, and so on. So in order to actually make this happen, I'm going to show you pictorially how things are done, and then when we go to the demo, we'll actually look at the code and see how we can create these objects. So there are two kind of roles. What we call role, and the other one is ClusterRole. So a role basically is namespace bound, and it consists of the resource or resources that we want to give permission to, the namespace that those objects will be residing on, and the verbs that we assign to. So in this case, we want to give pods in namespace 1, and these are the permission that we want to give access to. So get, list, watch to pods in namespace 1. So this will be the role object. And then we need to then create a role binding, basically, that will allow us to assign a person or a group that the person belongs to, and we bind it to this role. So in this case now we assign John Doe into this role binding. So John will have access, will have get, list, watch permission in namespace 1 to all the pods. So this is the role. We also can have ClusterRole. So that would be the scope will be cluster. And this consists of resources and verbs. There's no space here, no namespace here, because this is a cluster role. The scope is cluster. And we can assign it, for instance, pods, and the verbs such as, again, get, list, watch. So in this case, this pod apply to all the pods in all namespaces. They're not bound to any specific namespace. Then we can create a ClusterRole binding and then add, for instance, Terry Jones into this role binding. So Terry will have get, list, watch permissions to pods in all namespaces. So this is a very broad permission, and maybe sometimes it's not desirable. What we could do is we could create a role binding and then assign a person such as Jane Doe to the ClusterRole binding. So what it means is that Jane will have get, list, watch permission to all the pods within the namespace 1. So the advantage of creating the ClusterRole binding is and assigning them to role binding is that, for instance, if you have 10 namespaces, you can create 10 different roles and create 10 role bindings within each of those. But the other option would be to create a cluster role, which is like this one we created, like read access to pods, and then assign them to various people within the various namespaces. And that kind of lessen our work. Rather than creating 10 different roles, we only create one cluster role, and then we'll have 10 role binding that are bound to that cluster role. So the rest of this video, we are going to create, first of all, various users such as Terry Jones, Jane Doe, John Doe. We'll create those. We will be using client X509 certificates. So those, again, client certificates are the default manager client in Kubernetes. So we'll create certificates for those. I'll walk you through how we can create certificates. Because when you have a new user in your cluster, obviously you don't want to give everybody, cluster admin access to all the resources, because that's dangerous. You have to be very precise. And so RBAC gives you the tools and knowledge how you can create give access to users for specific purposes. So rather than everybody having admin access, which is a bad security practice, you can give them the access they need, nothing more, nothing less. So that's what we're going to do in the upcoming demos. In this section, we'll be creating certificates for our new users who are John Doe, Jane Doe, and Terry Jones, as we described earlier. So here's the process. First, we need to create what is known as a certificate signing request, or CSR. Then once that we generate the CSR, we submit it to Kubernetes, which is our certificate authority, and Kubernetes will generate a certificate for our user. And then we need to create a config file for the user. The config file basically consists of information about the cluster name, the IP address, the port that is listening on, and also will include the certificate, the client certificate, both that has both the public and private keys. And then you can then send that config file to the user, and user can interact. And then obviously we need to give them access to resources, and that's part of the RBAC role and role binding that we'll be talking about a little bit later. So the first thing that I'm going to do is I'm going to save the IP address of the API server in a variable called master_IP_address. And then on line 4, we need to generate a private key for the user. And I'm using OpenSSL. So it's usually installed on most Linux environment. If it's not, you can download it and install it. So once you install that, then the command is OpenSSL gen RSA-out, and the name of the file in this case would be john.doe.key, and the size of the private key, which is 2048. So let's go ahead and create that. Then on line 8 and 9, we're going to actually generate the CSR. So this is the command, OpenSSL request, REQ, -new, -key, and this is the reference to the private key that we generated earlier, and then -out, so the output would be another file called john.doe.csr. So this is our CSR that we'll be submitting to Kubernetes. And subject, let's go through this, CN. So this is basically the name of our user, equal to John Doe, and then O equal to, so this is the organization, units, organization groups that the user belong to. And I'm assigning John to a group called marketing-lead. And I highly recommend that you create various groups for your users so you can assign them, all of them the same permissions when you assign them the roles and role binding. So this is very, I would highly recommend doing that rather than dealing with individual users. Or you can also work with individual users if you want to. But anyway, let's go ahead and then create that. So it generated that. Now on line 14, we need to embed that what we created earlier into a base 64. So we cat open that file, john.doe.csr, and then we pump it into base 64, and then we remove the trailer and the header, and then we pump it into a file called john.doe.base64.csr, because that is what Kubernetes expects us to send it. So let's go ahead and do that. And now, finally, we are ready to submit our request to Kubernetes, and this is the command. Let's go through that. So the kind is certificate signing request, and then the name, we give it a name, the request, that would be John Doe, and the groups, it's always system authenticated. So this is This is nothing to do with like the marketing group that role that we created. This is strictly within Kubernetes, and always you need to set that to system authenticated. And then for request, basically we open the John Doe base64 CSR, automatically open that, and then once this is submitted, then the content of the CSR also will be sent to Kubernetes. And then the signing name, this is Kubernetes itself, so this is always will be this. And then under usage, client auth. So because this is a client certificate, so it will always be -client auth. So let's go ahead and run this. And you see that it was created. So let's go ahead and clear that. We can also verify that on line 14, kubectl get certificate signing request. Let's go ahead and do that. I'm going to see only have one, which is John Doe, and the condition or status is pending. On line 37, kubectl certificate approve John Doe. So we need to approve the certificate as an administrator. And you have 1 hour. Just remember, you have 1 hour to approve it. If you don't do it, then it will garbage collected and will be deleted. So let's go ahead and approve that. And then on line 48, let's do another status. kubectl get certificate signing request and specify John Doe. Let's go ahead and do that. And we'll see that John Doe, and the condition or the status is approved and issued. So now that we have that the certificate is, or the request has been approved, now we need to get the certificate actually from Kubernetes and extract that from Kubernetes. So this is the command, kubectl get certificate signing request, John Doe, and we're going to send it into the JSON path. And what you're looking for, the attribute is called status.certificate, and then we pumped it into base64, and we want to decode that because it was generated in base64. We don't need base64 anymore. We decode that, and then we save it into a file called johndoe.cert. Basically, the certificate that was, we can then, this is certificate that we get it from Kubernetes for John. Okay, now that we have the certificate, now it's time to actually now create a configuration file for our user John. So the first section that we want to do is on line 48, kubectl config set cluster. So basically, we're going to set the cluster information for the configuration file. The server name, the server will have HTTPS / and then master _ IP _ address. So that is the IP address of our master, basically, that we created early on, and the port is 6443. This is the default port. And then certificate authority again would be Kubernetes itself. And embedded certificate truths basically will also include the content of the certificate inside the config file. And this is the name of the config file that will be created. So let's go ahead and create that. So this is one section of that config file, the john.doe.config. So we created the first section. We also need to create other section. This one would be on line 55, kubectl config set credential. So we need to set the credential for John Doe, and the client key is the client certificate, the client key that we created early on, and the client certificate is John Doe. This is what we got from Kubernetes, and embedded CSR again is true, and then again the name of the file is config.john.doe.config. So again, it's going to add. So we created this file earlier. Now it's going to augment that and add this section to it. And finally, we're also going to create a context for for the user. So kubectl config set context, and then we set it to john.doe at Kubernetes, and then the cluster, this is the cluster name, and this is the default name. If you change it during setting up the cluster, you need to set it to whatever the cluster name is, but this is the default name. And then the user is John Doe, and again, the configuration file is called johndoe.config. So let's go ahead and run this. So that will also create a complete configuration. So in order to take a look at the completed information that, let me just first clear this. The configuration file that we created, you can do kubectl config view --config is equal to john.doe.config. Basically, you're going to read the content of the config file that we created. You can also open it in a note, in Nano or whatever your favorite editor is. You can also see the same information inside. So basically, this is the configuration file that was generated for our user John Doe. Now, the other certificates are really exactly the same. The only difference is I've assigned them to different roles. So this one, Jane would be in the marketing/lead, and Terry would be in the marketing -admin. So now we are ready to create role and role binding for our new user, John Doe. The first thing that we need to do is create a new namespace. So all the tests will be done in the namespace called marketing. Let's go ahead and create that namespace. Now that we have that. On line 3, we can use impersonation to see if John has any access to the marketing namespace. And this is very convenient when you create your new user. If you want to test to see if the new user has access to the resources or not, then you can use kubectl auth can-i, and the verb that you want to use, in this case, list pod, the resources that we want to test against, and then the name of the namespace, and then --as equal to John Doe. So let's see if John Doe has list pod access in the marketing namespace. And the answer is, of course, no. We just created the namespace and he doesn't have any access rights to that. Next step is to create a role for that. So I'm going to create both role and role binding in one go, and then submit that to Kubernetes. So let's go ahead and first look at the first section, which is to create a role. So the API version is rbac.authorization.kas.io v1. So that would be the API version. The kind is role, because you're creating the role here. And then under metadata, we give it a name. The namespace would be the marketing. Again, recall that roles are governed or bounded by namespaces. So we need to specify a namespace. In this case, would be marketing. And then we give it a name. I call it marketing-pod reader. And then under rules, so these are the verbs that we're going to give John permission to. The first thing that we need to specify is the API group. So what API group the resource is under. So we're looking at pods, and pods are under API groups, the V1 API. So when we say -API groups, and then this, inside the bracket, we can have multiple API groups. So the one that we specify here is empty. Basically, empty is quote. There's nothing inside that. That means that, so the empty code represents the core API or API V1. So the V1, the resource that you're looking for is under /V1 API group. And then the resource name that you're looking at are the pods. Now, if you want to be more specific, like if you don't specify anything. So the pods would be kind of the resource that all the pods in the namespace will be, this rule will be applying to. But it could be, if you want to, it could be actually more restrictive. You can say resource name and then add the specific one or more, for instance, this came pod, can add only apply to this pod, like marketing pod, and can have multiple of those, and comma, and the list of separated resources by comma. Well, in this case, I'm just I've commented out because we want to give John list access to all the pods in the marketing. And then the verbs that are applied in this case would be get, watch, and list. So this is the first section, which is the role. The next section is role binding. So the kind would be role binding. And the metadata, the name, we give it a name, I call it marketing pod reader dash binding. And again, this is the role binding. So we need to specify a namespace. Again, that would be marketing. And subjects is basically the user. In this case, we can, I'm adding a user specifically, so the kind would be user. It could be group, and I'll show you in the next example. And the name would be John Doe. And then API group, so this is for, again, RBAC.authorization.ksio, so that would be the API group that applies to here. And then roles ref, so the kind would be role, and this must be role or cluster role. So in this case, we are dealing with role, so the kind would be role. We can also have cluster role, and I'll show you in the next example. And then the name is basically the role that we created for John earlier, so that would be marketing dash prod, pod dash reader, so that would kind of tie. This is how the role and role binding are tied together, is by specifying the name of the role that we specified earlier. So let's go ahead and select all of this and then run them. Let's go ahead and execute that. And you can see that the role was created, and then also the role binding was created. So we successfully were able to give a role, John a role in the namespace marketing. And now we can test again on line 33. kubectl auth can I list pods, and then again in the marketing namespace dash as John Doe. Let's go ahead and run. And in this case, the answer is yes. Recall that earlier it says no, but now that we gave him permission, the list basically read access to the pods, the answer is yes, you can do it. You can also see if on line 34, kubectl can I create deployment in the same namespace marketing. And again, we impersonate John dash as John Doe. Let's go ahead and do that. And the answer is no, because we did not give him that permission. So the permission again were get, read, watch, and list. So that would be the only access that he had. Okay, now let's create a role, cluster role and cluster role binding. Let me go ahead and clear this. So this is very similar to role, a role binding. The kind would be cluster role. Again, we select a name. I select cluster-pod.reader. And the rules, again, is very similar to those. Get, watch, list. And then to create a cluster role binding. So again, the only difference is than previous one, we now have a cluster role. We define a cluster role binding. Again, I give it a name, cluster-pod-reader.binding. And then the subjects, in this case, I'm going to use groups instead of user that we had previously. And the name of the group will be marketing-admin. So this is actually when we created the Terry Jones certificate, I assigned them to marketing-admin. So rather than dealing with users, we can actually deal with groups. It's a lot more convenient than for individual users. So that's the best practice in my opinion. So anyway, and then under again for role reference, the kind would be ClusterRole, and then we specify the ClusterRole pod reader that we created early on, and so this is very similar to that. Let's go ahead and run this. So we'll create a ClusterRole and ClusterRole binding for the group that Terry Jones belongs to. Okay, so it will create it, both the ClusterRole and ClusterRole binding. We can see that. Now we can test whether John will be able to perform tasks. So we're going to use impersonation again, but this time you're going to use a different method for impersonation. The reason for this is because we specify the kind group here, we're not dealing as individuals, so I can't say run as dash as John Doe as we had over here. So another technique that we need to use in this case, we need to actually use the configuration file that we created for John Doe and use that as a method of connecting to Kubernetes. So line 25, kubectl config, use context, and the context would be Terry Jones at, that would be Terry Jones, and then dash config equal to, this is a config file name that you're going to use. Basically, you're going to use Terry Jones configuration file, and we're going to set it to the context called Terry Jones at Kubernetes. So let's go ahead and do that. We set the context for the current user. And then on line 26, kubectl odd can I list pods -n marketing, and then we dash kube config file is equal to terryjones.com. Let's do it and run that. And the answer is yes, because we just gave the group that Terry belongs to, give it read access to pods. On line 28, let's do another test. kubectl can I list pods -n in the default namespace. So rather than marketing, let's see if Terry has access in the default namespace. And then dash config file is equal to Terry Jones's configuration file. Let's go and run that. And the answer is yes, because this is a ClusterRole binding. So Terry Jones will have access to all the pods in all the namespaces. And finally, line 30, kubectl can I create deployments in the namespace, in the marketing namespace? Let's go ahead and try that. And the answer is no, because we did not give him permission for creating deployments. So the last section, we're going to create a ClusterRole and then binding to a local role binding. So on line 3, the first section would be on the ClusterRole, and then we give it a name, call it cluster-pod.reader-role. And then everything else will be the same, API groups, resources, and verbs, same as before. And then under the next section is the role binding. So this is a ClusterRole binding. We are binding it to a role binding. So for a role binding, we also specify a name for it. I call it marketing-pod-reader-binding. And the namespace is marketing. And the subject user is kind and Jane Doe. So we're working with Jane Doe. And everything is the same, except under the kind, we are binding it to a ClusterRole that we created earlier. And this is the name of the ClusterRole again that we were creating in this section. So let's go ahead and execute this. And we see that the cluster role and the role binding has been created. Okay, now let's do some testing. So on line 26, kubectl auth, can I list pods in the marketing namespace as John Doe? So let's go, Jane Doe, sorry. Do I go ahead and do that? The answer is yes. Let me get clear this. Because the role binding is in the namespace marketing. On line 28, kubectl auth, can I list pods, but this time, can I do it in the default namespace as John Doe? And the answer is no, because although we created a cluster role, but we created a binding specific to the marketing namespace. So Jane Doe will not have access to any pods in the default namespace. And finally, kubectl, can I create deployments in the marketing as Jane Doe? And the answer is again no, because Jane Doe does not have deployment permission in that namespace. RBAC allows cluster role aggregation. So what does that mean? It means that you can a cluster role can inherit rules from other cluster role. Let's say we have a number, we create a number of cluster role. Let's start from the bottom. We have one is called manage pod, and the resources that it includes are pods and logs. So pay attention that pods and the logs that come with them, they're actually they're considered two different resources. So these are the resources that are assigned to or associated with the pods and pod/logs, because the logs are within the pod. And then these are the permissions that we want, or verbs or permissions that are assigned to these resources. So pretty much everything. And then note that we create a label called, I call it acme.com/aggregate to support equal to 0. So we're going to create a new cluster role called support, which will inherit all these permissions and rules from these cluster roles. We have another one called manage endpoints and services, and the resources that includes are endpoints and services. And again, these are the verbs or permissions that are assigned to those resources. And then note that we assigned the exact same label that we assigned to the previous one, and so on. And this one called deployment, and the same thing. And then again, we have the same label, and finally a daemon set. So called manage daemon set. This is for managing daemon set, and again, all the permissions that are assigned to it. And again, we assign exact same label to it. Now let's say we want to create a new cluster role that inherits all of this. It's actually pretty easy. This is the YAML. So the kind will be cluster role. And then we have under metadata, we have the name, which I call support. So this is a support new cluster role called support. And then we have aggregation rules. So these are basically the rules of aggregation. So we use cluster roles selectors, and the match labels would be the name of the label that we created for all of them. So this is how all of these are tied together, and this is how all of this will be inheriting, this role will be inheriting all the resources and the permissions that come from these cluster roles. So once that applied, then it will create a brand new cluster role called support, and it will inherit all the resources and the permissions that come with them. Now let's say we create a role binding and assign Jane to that binding role binding. So Jane will have access to all the resources and all the permissions that are assigned within these groups. So next we're going to Visual Studio Code again and implement this. So let's go through the code here together, and we can review what's going on. So first we create ClusterRole named manage pods, and then we create a label as we discussed. And the label we create something called acme.com/aggregate to support equal to true. You can name it whatever you want. I'm just you don't have to use the same name. And then under rules, the API group. This comes under the core API group, so we don't specify any name here. And then the resources that we are interested in are pods and pods/logs. And these are the verbs that we want to assign to pretty much everything. And then we create another cluster role. This one is manage endpoint and services. And again, we assign the exact same label as the previous one. And under rules, again, this one comes under the core API groups. And the resources are endpoints and services. And then again, these are the verbs that we want to associate with it. And then the next one is manage deployments. And again, we create the exact same labels. And then under rules, the API group, this one comes under apps. So, and then the resources are deployments, and again, these are the permissions. And the last one is manage daemon sets, and again, we create the same label. This one also comes under the API, under the apps API groups, and the resource is daemon sets, and then again, these are the permissions. So let's go ahead and highlight these and run. And we'll see that it created all the cluster roles that we asked them to. So let's go ahead and clear that. Now, next step is to create the role, the support role that inherits all of those permissions. So this is, again, the kind is cluster role. The name, I gave it support, and their aggregation rules. We have the cluster role selectors, and under the match labels, we have this label that we created for the previously in other cluster roles. And then the rules, we leave it as empty because this will be automatically filled by Kubernetes. Once this is applied, then all the rules will be inherited from the previous cluster roles. So let's go ahead and run that. We see that this one was also created. So we have now the support super group that inherited all the permissions from the other cluster roles. Next, we are going to create a role binding. And within the marketing support, within marketing, and we call it marketing-support binding. And the namespace is under marketing. And subject, we're going to use user, Jane Doe. And then the reference would be the cluster role. And the name would be support, so the one that I just created. So let's go ahead and create that. And we see that it also created that role by. So we have the support cluster role, and we have the support marketing support binding, which is bind Jane to that cluster role. Now do some testing to see if everything we got done correctly. So on line 78, kubectl auth can I list pods in the marketing namespace and as Jane Doe. So let's see if Jane Doe has access to list pods. And of course she has, because now she inherited all those from the previous cluster rules. And on line 80, kubectl auth can I delete daemon sets in the namespace marketing as Jane Doe. So let's try that. And the answer is yes, because again, she inherited the permissions from the other, from the cluster role. And then last one, kubectl auth, can I delete daemon set in the marketing as Jane Doe? And again, the answer is yes, because that's what the inherited the permission. Now let's do something interesting here. Let's modify the manage daemon set cluster role that we created, and we changed the label to no. So it was it was yes, acme.com/aggregate to support. We previously had said yes for all of them. This one we're going to set no. So basically what we're going to do is we are going to pull this out of those inherited cluster roles that we assigned to support. See what happens. Let's go ahead and apply this. And you see that it was configured. Let me clear this. Now let's see if Jane still has access on line 108. Auth, can I delete daemon set in the marketing namespace as Jane Doe? And you see the answer is no, and now no, because we changed the label in that cluster role, and that cluster role will not, the support will not be, support cluster role will not be inheriting that cluster role. So in other words, Jane will not have access to do anything with the daemon sets. In addition to being able to create custom role and custom cluster role, Kubernetes provides some built-in cluster roles, and those are described here. The first one is cluster admin. It allows super user access to perform any action on any resource. When used in the cluster role binding, it gives full control over every resource in the cluster and in all namespaces. When used in a role binding, it gives full control over every resource in the role bindings namespace, including the namespace itself. So you got to be very careful with this, and only assign people to this cluster role if you want to make them cluster admins, or you want to make them admin at the namespace level. Next one is admin. It allows admin access intended to grant within a namespace using a role binding. If used in a role binding, allows read-write access to most resources in a namespace, including the ability to create roles and role bindings within the namespace. This role does not allow write access to resource coda or to the namespace itself. So you can't really delete or modify the namespace itself, for instance, the name of the namespace, but you can do other things that described here. This role does not allow write access to endpoints in clusters created using Kubernetes v122 and above. So this is kind of a little bit below that permission. The next one is edit. And this cluster role allows write access to most objects in the namespace. This role does not allow viewing or modifying roles or role binding. However, this role allows accessing secret and running pods as any service account in the namespace. So it can be used to gain the API access level of any service account in the namespace. This role does not allow write access to endpoints in clusters created using Kubernetes 122 and above. And the last one is view. It allows read-only access to see most objects in the namespace. It does not allow viewing roles or role bindings. This role does not allow viewing secrets, since reading the contents of the secrets enable access to service account credentials in namespace. So basically, you can assign it to people who, if you want to just give them read access to most objects in a namespace. So this is it for this presentation of RBAC. I hope you enjoyed. If you do, give it a like and subscribe if you haven't done so. Also, if you want to see more security in Kubernetes, mention that in the comment section, and we'll go from there. Thank you.